Have you solved these before? No, yes? Some of you no, some of you yes. Okay. Do you see now I have a fraction equal to a fraction? When I have this, this is called a proportion. Heard of those before? Proportions? Fraction equal to a fraction. I'm asking you to find a value of x that makes this true. Here's how we do it. It's going to be pretty easy. We do a method called cross multiplying. All right, cross multiply. When you have a fraction equal to another fraction, what I want to do is cross multiply. And here's how I cross multiply. Top left with bottom right. All right, top and bottom. Cross multiply. So what do you end up with there? 60 equals cross multiply 3x times 10, 30x. Can we handle solving that? Yep. X equals 2. All right, no issues. I'm going to turn it over to you guys. Cross multiply when you have two fractions equal to each other. Need two people right now. First person, you can cross multiply anything you want and let me know what you end up getting. 9. Go ahead, cross multiply anywhere. 3y times 2, 6y. Nice job. Now be careful when you do 8 times y minus 5, because what are you going to have to do with that 8? Take a look. 8 times y minus 5. You're going to have to distribute that 8. So go ahead, somebody help your classmates out. Distribute the 8. 20, distribute that 8. No 20 today? All right. Here you go. 2, distribute the 8. Yep. Go ahead, guys. Move the y's to one side. Solve for y. And I'll ask somebody what you end up getting. When you're ready, 20, yeah, never mind. When you're ready, 21, let me know. What do we get for the value of y? 20, yep. All good? Huge issue when you get to number 3. It's not a fraction, it's just 14. Oh, so make it into a fraction by putting it over 1. Got it. Now you can cross multiply. That's about as tough as they're going to... Actually, I shouldn't say that. That's the biggest problem you're going to run into, I guess. 12. Can you cross multiply both sides for me? 42 equals now 14 times w minus 2. Yeah. There we go. Fraction equal to a fraction, cross multiply. Seven, when you're ready, let me know what you have. Yep. You guys all right? Okay, how is it going to get tougher? All right, take a look at the next one. Here's how it's going to get tougher. You're still going to cross multiply for me, please. 12 times 12, x times x plus 7. All right, set them equal to each other, and then we'll talk. So go ahead, do cross multiply right now. Here's some people. 10 when you're ready. Ooh, x squared plus 7x. Got it. Thanks, Matt. Everyone see the squared up there? Is anybody at this point in the year saying, oh boy, if I see a squared, I'm probably going to have to factor. Yep. Or use quadratic formula or complete the square. Remember, you have 3 methods. If we're going to factor, I got to do what to the 144? Boot it over. Yep. x squared plus 7x minus 144 equals 0. Now, you could have kept it there and completed the square. Again, I'm not a big fan of completing the square if it's an odd b value. From here now, I'm going to factor it, but you could also use quadratic formula. Are we okay? Either way, you could use either way, factored or quadratic formula. Woohoo, 144, big number. Big number. I'll let you guys play around now. Finding two numbers that multiply to 144, 7 apart. You got it. You've been trained well. You got it. Numbers, here we go. What'd you find as your numbers here? 7 numbers. 16 and -9. We got a winner. Adds to 7, multiplies to -144. Draw your line down. Set each factor equal to 0. So x equals -16 and x equals 9. Any questions? I'm going to walk around, watch you do number 5 now. Go ahead. I'm going to walk around, watch you do number 5. $12, cross multiply for me. What'd you end up with?
X squared plus 6 equals 6.
What'd you get? X squared
X squared plus x
equals.
6.
Okay, from there, what did you do? 4, what'd you do from here? How? Yep. What'd you factor it into? 3. I don't want to hear from you. You're good. Thanks. Plus 3, minus 3, plus 2?
Yeah, plus 2.
You're killing me. Values of x, 17. Solving when 2 fractions are equal. Everybody all good? Questions? Okay, put that packet away. You know where we're going now? Regents packet. And I don't know if you took a look at the schedule I gave you, but I'm handing you a new one tomorrow. Okay? Today and tomorrow, the last times in class, we're going to talk about that unless you want to come in and talk with me about it after school. Okay? I know we've done it already. Nobody needs to tell me. Back over there. Everyone's starting to see this is going to be a little challenging, correct? All right, going to be a little challenging. We just can't roll out of bed, and that's it. Everyone agree? All right, let's keep grinding it out. I know we already did 5. Somebody asked that, so we can just move along from that one. What does he have on store next? What's he have on store next? 8. Before we answer this question, because I don't even know if you guys even sniff this, rational and irrational. Anybody want to give me an example of an irrational number? Marco? 3. Okay. Okay. So actual numbers. Could it be negative too? Sure. All right. So I'll just put plus or minus there with you guys. Yep. How about 1/2? Yeah, that's rational. Okay, that's 1/2. How about 2.85? It ends. It ends. Or 1/3. If you do 1/3 in your calculator, go ahead. 1/3. It repeats. So that's what a rational number is. All right, it ends or repeats itself. Versus irrational, pi. To go ahead, just do pi in your calculator and see that 3.14. Is there any sort of pattern to it? No, it just keeps going on forever. All right, so a number like square root of 2, there's another famous irrational number. Because if you do the square root of 2 in your calculator, it's just a number that goes on forever. All right, so without any repetition, it's irrational. So everyone, which one's not always true? All right, so if I add, oh boy, this is going to be good. If I add 2 rational numbers together, do I always give a rational number back? Is that always true? Why are you shaking your head? Give me an example then. That's 1 plus 1, which is 2. But that's irrational. It's asking me, when you add 2 irrationals, will you always get a rational back? So if you add any of these 2, will you always get a rational back? Yes, so that's always true, so that's not going to be it. If you multiply 2 irrationals, is it always rational? Wow, that's a mouthful. So when you multiply product 2 irrational numbers, will you always get a rational back? Okay, everyone ready? You guys just told me pi was irrational, right? So do pi times radical 2. Do pi times radical 2. Multiply 2 irrationals together. Does that number have any pattern or repetition to it? Anybody? No, so that's not the case, right? Not all the time are you going to get the product of 2 irrationals is irrational, so that's not always true. Everyone all right? Questions? Go ahead.
Saying that the product of 2 rationals can be rational, but it's not always rational.
Because watch, ready? In this case, ready? When I did pi times radical 2, irrational times irrational, what did you get? Irrational, right? That's not always the case sometimes, though. All right, but this is saying, oh, wait, not always true. Because watch, Marco, ready? Do radical 2 times radical 2. And which is what type of number? Okay, but it's not all the time, though. Okay, so that's why the question is not always true. All right? Whew. 17. Oh boy. How much do we remember? Well, I got to ask first, did you do it? Whew. Ooh, that's cool, huh? The value of a comic book T years after its purchase. What's the rate of appreciation? Okay. Well, do you know where I got to look first in that equation? Where do I have to actually look first? In the parentheses, all right? So what am I going to do now with this one? Because this isn't the answer. Hey, this is, I know they put it in choice 3 for you to pick it. That's why. All right, but that's not the rate. Okay, that's not the rate. Anybody want to add anything in here before I start reteaching this? Matt, you want to add in something? Okay. How do I get the actual percent rate from that number right there? Emma, go ahead. Anything?
Take out the 1, you have to split them up because the 1's telling you that it increases. And so then when you have the 0.017, you just move it to where it could be.
It's not bad. Not bad. All right. The 1 is just, if this number is bigger than 1, that's just telling me it's increasing. Okay, if this number is bigger than 1, which it is, so I, like Emma just said, yes, I get rid of the 1, and now I'm down to 0.017. That, hey, everybody now, that's the percent as a decimal. That's not my percent. And again, that's why they threw that up there as number 4 for to fall in the trap. That is whatever the percent is as a decimal. Hey, quick question. If I have 5%, what's the decimal? 0.05. If I have 12%, what's the decimal? 0.12. What are you guys doing to get to that decimal? You're moving it to the left 2. So if I want to get the percent, instead of moving it to the left 2, I should move it to the right 2. So what was my percent then? 1.7%. Yes, Marco. Correct. So here you go. Let me change this up on you. Let me do 1350 times 0.86 to the T. No. Okay? So if this is less than 1, this was decreasing. And I know you're going to say it's 86%, but it's not 86%. All right? It would be 1 minus what would give you 0.86. That's where that number comes from. Okay, so go ahead. 1 minus what would give me 0.86? 0.14. Guess what the percent was? 14%. Okay. Caitlin, you had a question.
No, I have the same question.
Okay. So if it's decreasing, you're going to see a number less than 1. And be careful, because this is not, the rate wouldn't be 86%. It'd be 1, bless you, it'd be 1 minus 0.86, which would be 0.14. Okay? Anybody else before we leave this one? All right, here we go. This is right in our wheelhouse. What we just finished up last unit. What are the solutions? Guys, look at the multiple choice. Do you think you're going to be able to factor this? Just by looking at the multiple choice, do you think you're going to be able to factor it? No, because when you factor, you get whole numbers as your answers. And obviously, looking at the multiple choice, that's not whole numbers. What are the other 2 methods I could solve then if I can't factor? Complete the square or quadratic formula. Class decision, what do we want to do here? Complete the square? Okay, because it's already there. Is the A value 1? Yes. Is the C value moved over? Okay, so the first 2 steps in completing the square are already done. Okay, anybody remember the 3rd step, how to find the new C value? Go ahead, Matt. Divide the B value. So everyone ready? Do it with me. -8 divided by 2 is -4. Square it. X squared minus 8x Plus 16. Anybody else? Add 16 to the 24. Yes. Completing the square. Factor the left side, because I know this side's going to be 40. Factor the left side. Anybody remember x? Be careful. Where'd the minus 4 come from? It was half the b. Nice job. Next up. X minus 4 on the left. What about on the right? Plus or? Okay, everyone, let's stop right here. Everybody stop. Everybody stop. Don't touch the negative 4 on the other side. Do you see any square root of 40s up here? No, here's why. Because they simplified it like I started showing you the other day, the unit that you completely missed, which was not your fault. All right, so I need your help breaking down 40 now. Remember our perfect squares. What were our perfect squares? Ready? 2 squared. 3 squared. Okay, out of these, which one's the biggest one that goes into 40 evenly? Evenly, no remainder. 4 goes in, right? Okay, so remember how we did this. Plus or minus 4, because that was the perfect square you guys picked. What do you multiply 4 by? 10. Square root of 4. And remember what we did with the other square root? Just brought it along for the ride, right? So again, we picked the biggest perfect square. I think I went over this the first day we did the regions. Pick the biggest perfect square that goes into 40. That was 4. Times 10, square root of 4 was 2. Now what do you want to do with the 4 to bring it over? Add it, so it'd be positive 4 plus or minus 2 radical 10. Yep.
Why wouldn't you add the 4 to 2?
Can't.
Oh,
Because the 2, this isn't 2. This is 2 times radical 10. So it's attached to it.
So if you added the 4, it would be
No. Correct. Okay. And this will be the last one we do. $33. Big Al. He says they had the same solutions. Is he right or wrong? All right, here we go. First system. Let's tackle this one first. We went over the other day 3 ways you could solve it. You could graph it, which I wouldn't recommend on this one because of the 48 and the 21. You could substitute or eliminate. I'm going to choose to do elimination here. Is there a number you can multiply, a whole number? I don't want to deal with fractions. Is there a number you can multiply by 8 that'll get rid of the 12? Shoot. Is there a number you can multiply by the 9 that'll get rid of the 5? Yes, no? No, so we're kind of stuck. If that's the case, do you guys remember multiplying both of them by a different number so either the x's or the y's cancel out? Okay, so I need your help right now. You can discuss it in your group if you want to. About 30 seconds. What can I multiply the top one and the bottom one by so either the x's or the y's cancel each other out? And there's unlimited answers here. Unlimited correct answers. There's not just one set of right answers. Any group want to share? What do you guys want to do? Multiply the top one by 3. Well, hold on. If I do that, that'll be 24, and that's still 12. Okay, hold on, though. Even when I do that, I still have a problem. Because watch, that'll be 24, positive 24. That'll be positive 24. They're not going to cancel each other out. I got to make one of them negative. Okay? I got to make one of them negative. So we'll go with 3 and negative 2. All right, now I'm going to open up to you guys. Make sure when you distribute the 3, you distribute it all the way across the equation, including after the equal sign. So go ahead, distribute the 3 all the way across. Here you go, 8. What do you end up when you distribute that 3 all the way across? 24x plus 27y equals 48 times 3? 144. Nice job. Okay, somebody else, I'm going to need to distribute that negative 2 all the way across. Here you go, 9. Can you distribute that 2 all the way across? All right, thank you, everyone. Okay, combine now. What crosses out? That's what I wanted. The x's go. 27 minus 10. 17y equals 144 minus 42. 102. Divide by 17 on both sides. Y equals 6. That's halfway. What do we still have to do? Find the x value, right? So store it, plug it in, however you want to do it right now. Take 6, plug it in for y right now, and solve for x. Go ahead. I'm waiting. Take 6, plug it in for y, solve for x. And then we'll get to the other two, the second system. So if y equals 6, plug it back into one of the two originals and solve for x. When you guys are plugging it back in, what are you getting for the value of x? 22 when you're ready. Oh, shoot. 20 when you're ready. Perfect. 22, perfect. 14. Can I get a confirmation on that? I'm seeing some yeses and some nos. All right, I'll plug it in. 8x plus, when I plug in 6 up here, I get 54 equals 48. 8x equals, what's that, negative 6? X equals negative 0.75. Everyone all right there? All right, let's see now about the second system. And this will finish this up for today. Looks a little different than the last one. Take it in right now. Don't start going nuts. What's it pretty easy to find right now? Which values are pretty easy to find? I'm not even talking about any elimination or anything what we just did. How can I just find y pretty easily? Divide both sides by? Yeah, I don't have to do any special elimination or anything here. I'm just going to divide both sides by negative 8.5. Do I get out 6? Negative 51 divided by negative 8.5. Let's go, let's go. We got some stairs. Let's go. Negative 51 divided by negative 8.5. What do we end up with? Y equals? Okay, 6. Does that mean they're both the same yet? No, we still have to take 6 and do what? Go back and plug it in up here. 8. But take a look. Let's do this quickly. What do you notice? Same equations, right, that I just plugged it in before. So what are you going to get out? X equals negative 7.75. So what can we say about Big Al? He is correct. All right. And also, just let me go over this. This word justify your answer, that means you can show your work. You don't need to write a little essay for me, tell me why Big Al is correct. Okay, all you have to say is he is correct, and then your work is enough. Okay, if you want to get started on tonight's packet work, go right ahead. All right, you still got a few minutes. Get a couple of them done. Bring that Regents back tomorrow. We're going to hopefully not finish it, but get it pretty completed, and I'll give you the new one.